Hello everyone. Audio visualized recording for the inorganic chemistry from the books Pardeep Publications, whose writer is Dr. K.K. Basil. My topic is non-aqueous solvents. Now we will discuss about non-aqueous solvents. A solvent is generally defined as a liquid which has the ability to dissolve other substances. Water to be the universal solvent since ancient time. Majority of the reactions are also carried out because of its easy availability and unique physical and chemical properties. There are solvents other than water that can be used to carry out chemical reactions. Solvents other than water are called non-aqueous solvent. Before we discuss the chemistry of non-aqueous solvent, it is appropriate to understand important role of solvent play in chemical reaction. Roles of solvent in a chemical reaction. A solvent has two roles in a chemical reaction. The first and the most important role in the reacting substance close to each other in a finely divided state. If the reactant are not intimate fixed, the rate of reaction will be very slow. For example, the reaction between barium chloride and silver nitrate in the solid state will proceed very slow. However, in aqueous solution, the reaction proceeds very rapidly. Thus, the role of solvent is to accelerate the rate of reaction. In addition, it is possible for a solvent to change the course of the reaction. In water, barium chloride and silver nitrate react with twinkling of an eye from white precipitate of silver chloride. The same reaction in liquid ammonia is completely reversed. A solvent also affects the rate of given reaction. For example, the reaction between iodoethane and ethylamine occurs to form tetraethyl ammonium iodide at a reasonable speed in hexane. If the above reaction is carried out in benzene, the rate of reaction becomes 80 times that hexane. In acetone, the rate of reaction is 500 times, where in the nitrobenzene, the rate of the reaction 100 times. We can say rate of above reaction in various solvent proceed in the order. Another important role of the solvent is to allow rapid separation and purification of the products. The precipitation of the chloride in the above reactions allow for an easy separation of the products. Should recall that silver chloride is insoluble in water, whereas barium chloride is insoluble in liquid ammonia. Suppose you are asked to prepare an anhydrous sample of copper sulfate. How will you prepare? Definitely, you cannot use water as a solvent. This means we need another solvent. Anhydrous sulfate can be cleanly and conveniently prepared in the molten solvent mercuric bromide. Now the physical properties of the solvents are: the selection of the solvent in a reaction is generally made with regard to some specific properties that may help to carry out the reaction by effectively dispersing the reaction and separating the product more conveniently. Some of the important physical properties of the solvent are discussed below. Melting and boiling point. Majority of the chemical reaction are carried out in the liquid phase. As a result, the liquid range, temperature range between melting and boiling point determines the usefulness of a particular solvent. Melting and boiling point of several solvents. As inspection of table 8.1 reveals, the water has an excellent liquid range from 0 to 100 degrees Celsius. As a result, it is an ideal solvent for carrying out chemical reaction in solution at room temperature and atmospheric pressure. Both liquid ammonia and liquid sulfur dioxide are ideal solvents for carrying out reaction at a low temperature. Dielectric constant. Dielectric constant measures the polar nature of the solvent. The property is used to evaluate the solubility of a polar or non-polar compound in a solvent. According to the Coulomb's law, the force between the charged particle is given by this expression: F is equals to E1 E2 upon d r square. E1 E2 are the two charged particles. R is the intermolecular nuclear distance between the particles. D is the dielectric constant of the solvent. A high value of the dielectric constant indicates the force of attraction. F between the charged particle is less, hence a small amount of energy is required to separate the ions. It means that it is very easy to dissolve an ionic solute in a solvent of a high dielectric constant. In other words, it means that it is easy to dissolve an ionic solute in a solvent of high dielectric constant. In other words, dielectric constant determines the ability of a solvent to dissolve ionic compound. Thus, solvent with high dielectric constant should be able to dissolve ionic or polar compounds. Now the third is heat of fusion and vaporization. Heat of fusion is defined as the amount of heat absorbed by 1 mole of substance to change from solid to liquid state. Similarly, the amount of heat absorbed by 1 mole of substance to change from liquid to gaseous state is called molar heat of vaporization. The magnitude of the heat of fusion vaporization gives us some insight into the nature and the strength of force holding the molecules in a solid or a liquid state. A high heat of vaporization suggests that the intermolecular forces operating in the solid state are strong and vice versa. Therefore, the heat of fusion are particularly the heat of vaporization are significant in evaluating the usefulness of a solvent. The ratio of the heat of vaporization to the boiling point as the absolute scale degree Kelvin is a constant called Thornton constant, and it has a value around 2.21.5 for a normal liquids. Normal liquids are characterized by a single molecule without any bond between them. A value higher than 21.5 suggested association of molecules of the liquid to form larger aggregates. Such liquids are called abnormal liquids, which include ammonia, water, hydrogen fluoride, and sulfur dioxide. We have already learned that the molecules of liquid which undergo association are polar. Polarity in a molecule arises when the electron pair forming the bond is shared unequally between the two bonded atoms. Association between polar molecules arises the tendency of a polar molecule to orient themselves that the positive end of the molecule are near the negative end of the adjoining molecule. In addition, the polar molecules surrounded the positively charged cation in a way that the partially negative end of the polar molecule are oriented toward the cation. Similarly, the polar molecules surrounded the negatively charged anion in a way that the partially positive end of the polar molecule are oriented toward the anion. Water, being a polar molecule, oriented its negative ends toward the cation, forming the first shell of water molecule around the cation. Shows the polar molecule orient themselves around the cation. Now the viscosity. It is an important property of solvents. Viscosity measures the difference in the rate of flow of liquid and the liquid ammonia and the lower alcohol flow rapidly after gravitational force and how low viscosity is there. Whereas the high molecular weight hydrocarbon and hydrous sulfuric acid are highly viscous and flow at such lower rate. Viscous liquids lower the mobility of ion, thus they reduce the electrical conductance of the solution of the electrolytes. Experimental difficulties with viscous solvent are observed in preparation, crystalline and filtrate process. Self-ionization. The acidic and the basic nature of the solute dissolved in a solvent depends primarily upon the self-ionization of the solvent. Any solute that by direct ionization or interaction with the solvent gives the ionic characteristics of the solvent resulting from the self-ionization of the solvent is called acid. Similarly, the base is any substance that gives the anionic characteristics of the solvent. Self-ionization of the some solvents are types of solvent. There are four types of solvents which are protonic and non-protonic solvent, acidic basic solvents, ionizing non-ionizing solvent, coordination and non-coordination solvents. Protonic and non-protonic solvents. Protonic solvent are those who have hydrogen, can be abstracted. Some of the commonly protonic solvents are. Non-protonic solvents are those who have hydrogen ion, cannot be abstracted easily. Frequently encountered example of such solvents are CHCl3, C6H12, liquid SO2. Acid and basic solvents. Solvents which are capable of donating hydrogen atom, like acidic solvent, which solvent are capable of accepting H positive ion, are called basic solvent. Ionizing and non-ionizing solvents. There are several solvents which undergo auto-ionization or self-ionization to different extents. Such solvents are called ionizing solvent. Frequently encountered examples are. This is another class of solvent which are non-polar and do not ionize all over. Such solvent are non-ionizing solvent. Example, benzene and hexane. Coordinating or non-coordinating solvent. There are several solvents which are capable of coordinating with the ions of solutes. Such solute are designated as coordinating solvents. Commonly used: ammonia dimethyl sulfoxide, acetonitrile, nitromethane. Liquid ammonia is a non-aqueous solvent. Liquid ammonia is one of the most thoroughly studied non-aqueous solvent due to the availability of the water-like properties. These days, liquid ammonia is very high frequently used as a solvent for many type of organic and inorganic synthesis. Ammonia is used to associated solvent through hydrogen bonding, although the extent of hydrogen bonding is far less compared to that in water. As a result, the melting and boiling point of liquid ammonia are lower than those of water. Some of the important physical properties of ammonia are in the table. The melting point is minus 77 degrees Celsius. Boiling point is minus 33.35 degrees Celsius. Liquid rate 44.4, and these are the main characteristics of the ammonia. Now we will discuss about the acid-base reaction. The auto-ionization of the ammonia gives NH4 positive and NH2 negative ions. According to the solvent system concept of the base and acid, or any substance that by direction ionization by interaction with the solvent gives the cationic characteristics of the solvent, resulting from the auto-ionization of the solvent behaves as an acid in the solvent. Similarly, a base in any substance which gives the anionic characteristics of a solvent, thus NH4Cl would behave as an acid, whereas KNH2 would behave as a base in liquid ammonia. Acid and base in a liquid ammonia are called ammono acid and ammono base, respectively. Thus, ammono acid are substance which is liquid ammonia furnishes NH4 positive ions, whereas ammono bases are substances which is liquid ammonia furnishes NH2 negative ions. A unique feature of a liquid ammonia is solvent into power to dissolve the alkali metal, and a laser extend the alkaline earth metal and aluminium. The metal dissolved to impart blue color. The blue colored solution is independent of the metal dissolved and has a broad maxima around 15,000 angstrom. The solution are extremely good conductor of electricity. As the concentration of the metal is increased, the solution become bronze colored. The dilute solution of paramagnetic, but the paramagnetic behave decrease with the increase in concentration of the metal. Highly concentrated solution have conductivity near as the high as a pure metal. It is believed that the blue color of solution due to presence of alkali metal ion and the free electron of ammonia. In dilute solution, the metal and electrons are stands for emanated species. Solution of the alkali metal in liquid ammonia are metastable. A small amount of impurity is sufficient as a catalyst of the formation of amide. A rusted nail will be capable of serving as a catalyst for the formation of sodium amide. However, if both alkali metal and the ammonium and extra pure, the alkali metal dissolved in liquid ammonia can be kept for many weeks at a low temperature, and one can recover the alkali metal evaporation of the solvent. However, when alkali earth metal dissolved in liquid ammonia are evaporated, the free metal are not obtained. Instead, Ammoniates of the type are obtained where M is alkali earth metal. Reaction of amino bases. The most common reaction in liquid ammonia involving amino bases are reaction of the amount in NH2 negative. Most commonly used amino bases in liquid ammonia is potassium amide KNH2 because of its high solubility in liquid ammonia. The solubility of a lithium amide and the sodium amide is very small in liquid ammonia. The reaction of such solution with metal ion in liquid ammonia are used to preparation of metal and metal amide and metal nitride. Care should be taken in handling the amide and nitride of lead, thallium, bismuth, respectively. Salt of these amino acid can be readily prepared by the reaction. A very strong base in a liquid ammonia, sodium uride, can be prepared by combining urea with sodium amide in liquid ammonia. It is important to note that the sodium uride cannot be prepared in water. Similarly, aluminium salt combined with the potassium amide in liquid ammonia to prepare for soluble amide complexes. Redox reaction, oxidation reduction reaction are well known is liquid ammonia wherein nitrogen and hydrogen of the ammonia undergo a change in oxidation state. First, redox reaction will where alkaline earth metal reducing agent in ammonia. Alkaline and alkaline earth metal dissolved in a liquid ammonia are strong reducing agent. These blue colored metal ammonia solution undergo a various of reaction in each the alkaline metal get oxidized while the other reactant get reduced. Redox reaction where ammonia act as a reducing agent. Catalytic oxidation of ammonia in the presence of platinum, reduction of metal oxide, oxidation of reactive metal, reaction of non-metal. Redox reaction where ammonia act as a solvent. A number of redox reactions are well known wherein liquid ammonia simply act as a solvent. Oxidizing reaction of a various oxidizing agent is weaker than in liquid ammonia than in aqueous solution. Nitric acid, very strong oxidizing agent in water but does not act as an oxidizing agent in ammonia. Similarly, potassium permanganate is a strong oxidizing agent in water but behaves as a weak oxidizing agent in a liquid ammonia. Potassium permanganate first reduces the potassium magnate and finally manganese oxide to the solution of a solid potassium in liquid ammonia. Ammonolysis. A solytic reaction is defined as the reaction in which the solvent molecule react with the solution splitting into two parts, one or both of the which may become attached to the solute molecule. In most of the cases, the solvatic process result in a increase the concentration of either the ion or a cation, which characteristize of the auto-ionization of the solvent. Nearly all covalent inorganic halide when dissolved liquid ammonia undergo ammonolysis. Ammonolysis reactant reactions with several organic substances which have been studied in detail in ammonolysis. The atom or the ion from the compounds undergo ammonolysis replaced by minus NH2. The organic halide which undergo ammonolysis boiling point of a liquid provides a mixture of primary, secondary and tertiary amines. Solvent formation. When a solution is dissolved in a solvent, the excess of the solvent is removed. The solid product obtained is most cases contain a number of molecules of the solvent attached to a solute by a chemical bond. Such a process is called solvation. In case of a solvent in ammonia is called ammonization. The bonding that is involved in ammoniates may be explained in the term of coordination covalent, hydrogen bonding or ion dipole interaction. Complex formation reaction. A number of complex formation reaction in liquid ammonia have been investigated, whereas similar as to the complex formation reaction occurring in a water. For example, zinc precipitate as a zinc amide in liquid ammonia, which get dissolved in excess of amide to form soluble ammoniates complex. Precipitation reaction. The formation of a precipitate when a solution of two compounds are mixed, one of the most common and familiar chemical reactions. These reactions are independent upon the solubility of the possible products in the particular solvent. As a solvent, precipitation reaction are highly dependent upon the solvent complexes. On mixing solution of barium chloride and silver nitrate in water, there is intermediate precipitation of a silver chloride. The reaction proceeds in the forward direction because silver chloride is Practically insoluble in water. However, the liquid ammonia, the direction of a reaction is reversed. It means on the mixing solution of a silver chloride and barium nitrite in liquid ammonia, it is barium chloride that is precipitated. The reaction proceeds in the forward reaction because barium chloride is particularly insoluble in liquid ammonia. Similarly, metal bromides and iodides are precipitated when metal nitrate and ammonium halides are mixed together in a liquid ammonia. Ammonium sulfate in liquid ammonia is used in precipitated any metal sulfide from any nitrate solution. Advantage of liquid ammonia as a solvent. Alkali metal dissolved cleanly in liquid ammonia without any chemical reaction. Alkali metal solution in liquid ammonia is stronger reducing the agent than hydrogen. The tendency of liquid ammonia to undergo solubilisis reaction is smaller than comparison to water. The solubility of the ammonium salt in liquid ammonia find extensive used in precipitating metal halide, sulfide and sulfates. Disadvantage of the liquid ammonia as a solvent. Ammonia have a lower boiling point, 33.35 degrees Celsius, and consequently has a smaller liquid range. This reaction in liquid ammonium can therefore be carried out only at low temperature and high pressure. Specially designed the apparatus and equipment is need to carry under reaction liquid ammonia. Liquid ammonia is hygroscopic and therefore the application needed to exclude moisture from the reaction vessel. It is an unpleasant smell. Sulfuric acid known as a non-aqueous solvent. Sulfuric acid is the most extensive study of the strongly acid solvent. It is good solvent for a variety of organic compounds. Most of the organic compound accept proton in a sulfuric acid and act as a base in it. Pure sulfuric acid 100% has a freezing point 10.371 degrees Celsius. It can be prepared by adding aqueous sulfuric acid to fuming sulfuric acid. The freezing point diagram for the H2 and SO3 system in the neighborhood of 100% H2SO4. A careful inspection of the table reveals that the sulfuric acid is highly viscous solvent, suggesting the highly associated number of the solvent through hydrogen bonding as a result of strong hydrogen bonding of the high boiling point is to be justified. Liquid sulfur dioxide as a non-aqueous solvent. Sulfur dioxide is a gas at a room temperature and atmospheric pressure. It can be easily liquefied and can be maintained in a liquid phase in ordinary Dewar flask. It is carried to a number of chemical reaction. It is non-protonic solvent. The dielectric constant of the liquid sulfur is also which makes it ideal solvent of the covalent compound and for the ionic substance bromine chloride and iodine monochloric thionyl chloride carbons disulfide phosphoric trichloride phosphorus oxochloride are miscible in SO2 in the whole proportion with few expectation like liquid sulfur dioxide is excellent solvent for the variety of organic solvent amine ether alcohol ester sulfide carboxylic acid and merceptans and are alkanes have only limited solubility in sulfur dioxide whereas alkenes and aromatic hydrocarbon have higher solubility in liquid sulfur dioxide. In the different solubility of alkanes and alkenes in liquid sulfur dioxide, that is basis of the refining of petroleum. Among ionic compounds, the iodide and the thiocyanate are in general most soluble in liquid sulfur. Autoionization. The electrical conductivity of a pure liquid sulfur dioxide can be explained in the term of self-ionization according to the following equilibrium. The thionyl in analogous hydronium and ammonium, whereas sulfide ion in analogous to the hydronium ion and amide. Reaction in the liquid sulfur dioxide. Acid-base reaction, solvatic reaction, solvation reaction, precipitation reaction, complex formation reaction, redox reaction with organic compound, amphoteric behavior. Acid-base reaction. Acid-base reaction, which are all neutralization reaction, can be better described as according to the solvent system concept, a substance capable of giving of cationic character of the autoionization of the solvent in acid, whereas an substance capable of giving the anionic characteristics of the autoionization of the solvent of a base system. Thus, compound are thionyl chloride and thionyl acetate are the acids of sulfur dioxide system. According to the all compound with the anionic sulfide are the bases of the system. For example, potassium sulfide and cesium sulfide are the sulfur dioxide. Solvatic reaction. The solvatic reaction is a liquid sulfur dioxide as much less common than in the water. Some of the reaction are reaction of diethyl zinc with sulfur dioxide in dry temperature. Solvolysis of binary halide, solvation of ammonium acetate. There are number of binary halides such as BCl3, SbCl5, SiCl4, SnCl4, VCl5 and MoCl6 which do not undergo a solvolysis reaction under sulfur dioxide. Solvation reaction. A reaction which is one or more molecules of a reaction is attached to a solute is called the solvation reaction. A number of such reaction are known in liquid sulfur dioxide. It is found that the more soluble compound from form solvate in sulfur dioxide. Typical example of solvate in sulfur dioxide system are Na.2 SO2, Na4SO2, and Ki4SO2. Precipitation reaction. Precipitate reaction are conveniently carried out in the liquid sulfur dioxide. Precipitation reaction are dependent upon the solubility of the possible product in a particular solvent. These are the number of compounds can be precipitated in a liquid sulfur dioxide carrying out reaction with soluble compound or a sulfur dioxide. Complex formation reaction. A number of reactions that involves complex formation are known in sulfur dioxide. Iodine is soluble in water, sulfur dioxide, but insoluble. But solubility increases tremendously on addition of potassium and rubidium iodide. The tremendous increase in solubility is due to the formation of complex Ki3 and RbI3. Similarly, the solubility of cadmium iodide and the mercuric iodide are increased by the addition of potassium and the rubidium iodide in the solvent owing to the formation of complex ion. A number of examples of complexes are SbCl6 negative, hexachloro antimonate involving antimony. Redox reaction. Liquid sulfur dioxide does not act as an oxidizing or reducing agent. It acts as a medium in which redox reaction may occur. For example, sulfur dioxide can reduce iodine. However, addition of tetramethyl sulfide reduces iodine to iodine ion in turn get oxidized to sulfate as a solution of a ferric chloride will quantitatively oxidize potassium iodide to free iodine. Reaction with the organic compound. Liquid sulfur dioxide is a useful medium for carrying several types of organic synthesis reactions. This is mainly because of the inertness and non-inflammability. Some of the important reactions are sulfonation of aromatic hydrocarbon, Friedel-Crafts reaction, addition of substitution reaction of bromine, amphoteric behavior. A number of reactions carried out in a liquid sulfur dioxide show striking resemblance of the behavior of amphoteric hydroxide in aqueous system. For example, treatment of aluminum chloride in a sulfur dioxide and the treatment of ammonium sulfide reaction in the formation of gelatinous precipitation of aluminum sulfide. If the gelatinous precipitate of ammonium, aluminium sulfide is rapidly treated with the excess of treatment of ammonium sulfide. The precipitate redissolved just as aluminum hydroxide dissolved in excess of a sodium hydroxide solution. Now, if the acid thionyl chloride is added to the resulting solution of liquid sulfur dioxide, aluminum sulfide precipitate, sulfur dioxide has been shown above to be useful solvent for the variety of reaction it is used to, especially in the refining of the petroleum product. It is very important. However, it is very toxic and has very unpleasant odor. At most care must be exercised it in used in view of the harmful psychology effect. Breathing large quantity of sulfur dioxide has been found to be fatal. Thank you.